welcome our speakers, Brian, to share the first session. Thank you.
Thanks, Abby, for the introduction. Hello, everyone. My name is Bram. I'm from Money Platform team. It's a department under TikTok Live. So today I will share with you guys the key fundamental in payment and wallet. So a little bit background of me. I graduated in 2021 from Indonesia. I'm Indonesian from Indonesia. Then I worked for one year in a company remotely from Indonesia. Then I joined TikTok in 2022. Uh, Previously, I'm working on anti-money laundering team when I joined TikTok. Then after a few months, I moved to money platform team on 2023. And overall, I have 3+ year experience as a software engineer, mostly in backend stuff. Next slide, please. Yeah, so today about the payment stuff, I will go through all the key fundamental things. The first two part is consumable and subscription. So we will go through the business domain of what item we have in the payment team. And for the third and fourth section, we will discuss about how we handle this payment in backend perspective. And the number 5 sections, I will share with you guys some of the best practice that I can recommend you guys to use as a daily life as a software engineer. So the first part is the consumables. So what is the consumables? Next slide, please. Okay. In terms of the definition, consumable is a digital item that can be purchased and used within an application or services. Typically, it depletes with use and can be bought repeatedly. The example of the consumables is virtual currency, such as like coins and gems, extra life in games, or temporary boosts. So sorry, go back to the previous slide. So the key point in the consumables is can be bought repeatedly and immediately. So for example, like coins, you can buy coins multiple times without waiting for any action to happen. If the payment is success, you can just buy a coins immediately. Okay. So here's the front-end example of the coins. One of the consumable item we have in TikTok Live is coins. So this is the screenshot that I put for TikTok Live page. So there's two key point here. The first one is SKU. SKU stands for stock keeping unit. It's an item identifier of a digital goods or digital items. So for example, here you can see there's a 70 or 350 coins option, 700 coins, and etc. So it depends on how you decide how to manage the items. You can treat the coins as one SKU, or you can also treat 70 coins as one SKU also. So for here, we can have, if you decide to have only one SKU, so means there's only one SKU here. But if you want to have a different quantity of coins as a different SKU, that's also possible. So each SKU is tied with different price also. So for example, like 70 coins have their own price, 350 that has their own price also. This price is also, we have a multiple price, depends on the region also. Okay, so the first flow, how to buy the coins is you can purchase the coins in the recharge page. So I also screenshot the mobile page, how to buy the coins. So you go to the recharge page, then choose which coins you want to buy. There's a multiple product. The difference is only the item, the number of the coins, and each product have a different price. Then if you click one of it, it will go to there's a pop-up to buy to complete your payment. Here you can choose the quantity. So if you buy twice, if you buy 2 items of 5 coins, you will get 10 coins at the end. And you can also choose your payment method. Then if you click the one tap buy, it will complete the payment, and then you will get the purchase completed. Then you can see the coins on your balance, and you can use the coins to do, for example, like live gifting. Okay, then for consumable, there's a term called ACK. ACK stands for acknowledgement. So as a developer, we are required to acknowledge the purchase transaction to confirm that the transaction was complete successfully. So if we already send the user the coins, we should do the acknowledgement to Google that tell Google that, oh, this whole transaction is already complete. If we don't send the acknowledgement, Google will auto refund the order after several days. So yeah, this one is the one of the important things in the the payment flow for the consumables. And for consumables, there's also a scenario or cases where the user cannot or user not able to finish the payments. So actually, usually there's two cases. For example, like the first one, user just cancel the order immediately. So they click the buy 10 coins, but they don't proceed to the payments. So yeah, they just cancel or they just swipe back, then the order will be canceled. And for another one is user pending payment for too long. So for some of the country, we have offline payment. So if the user cannot finish the payment within a certain period of time, the order will be canceled automatically. So the user won't get the coins because they don't finish the payment. Next page, please. Okay, so for consumables coins also, user can apply for refund actually. So if you think that the item is fraud or there's a system issue that you didn't get the coin properly, you can try to apply for refund. So refund is only applicable if you already finish your payment. You already received your item, then you think there's something wrong with the item, you can apply for refund to the channel. Channel is the payment providers. In this case, is usually Apple or Google. If you apply for refund, then it gets accepted from channel, user will get the money back. And as a developer, we should revoke the user's entitlements because we already give the user the coins. For example, we give the user 5 coins. If they apply for refund, because the user already get their money back, we should get back the 5 coins from the users. So overall, this is the life cycle of the consumables. It's pretty straightforward. So the blue box is the state of the purchase. And the one that have the uppercase underline is a notification we get from channel. In this case, is Google. So yeah, as I mentioned before, the user can initiate the flow, then the transaction either go pending or directly complete. So if it's complete, we will get the purchase RTDNs, means that we should give the users the entitlements because the purchase has already complete. Then as a developer, we should acknowledge the users. If it's go to pending, yeah, we can wait for the RTD purchase RTDN to comes, or if it's too long, the user can go to auto cancel, then cancel state the purchase. Then if we don't purchase, if we don't acknowledge the order, it will go to cancel also after a few days. Yeah, then if we acknowledge the order, it consumed, then everything is fine. Next slide, please. Okay, that's for consumables. It's quite straightforward. Now we can go to the subscription, which has more life cycles into it. So by definitions, subscription is providing ongoing access to content, service, or premium feature in the app. So people are charged on recurring basis until they decide to cancel. So for example, is the access badge to content in streaming services or loyalty badge. In TikTok Live, we can have a loyalty badge if you subscribe to a certain host. So you will get the badge and you also get the premium stickers. So you can interact with the host with this premium sticker if you subscribe to the host. Okay, so the key point in subscription is there's an auto renewable status. Auto renewable status means here, if your auto renewable status is on, means that you are agreed to be charged again to the next cycle, and then you will go into the next cycles because your subscription is renewing. If your auto renewable status is off, means that you are doing soft cancel to the subscription. Means that you are not going to be charged anymore, and then your subscription won't go to the next cycles. And then we also have an expiry date. So each subscription has its own cycles. So if your auto renewable status is on, your expiry date will be extended when there is a renew. But if your auto renewable status is off, the expiry date is the last date where you can enjoy the entitlement. So after the expiry date is already passed, as a developer, we should revoke the entitlements because the user is not entitled to this subscription anymore. So for subscription, we also have a purchase flow. It's very similar to consumables, to buy coins. But for in TikTok Live, we can choose the host first, which host we want to subscribe. Then we can choose the type of subscription, if you want to have an auto renewable subscription or only 1 month subscription. And you can also choose a different tier. Usually hosts can have let's say a silver, gold, or diamond tier. We can choose each tier. Each tier has their own benefit. Like for example, higher tier, more stickers, something like that. Then the user can complete the payment and will got the benefit such as the loyalty badge or also the premium stickers. So this screenshot is for Apple screenshot. We are using Apple Pay. So it's very similar to Google actually, but just a different phone. Okay, so the first life cycle in subscription is cancel. So we can cancel a subscription. When subscription get canceled, the subscription state will go to the turn off. Will go to cancel, means that the user turn off the auto renewals. But the user still can enjoy the entitlement until the expiry date time, but the subscription won't renew to the next cycles unless the user reactivate the subscription. So in TikTok Live, you can go to the settings, choose live subscription, then choose the host that you subscribe. Then you can cancel the subscription. Next slide. Okay, so the opposite of cancel is reactivate. Reactivate can only happen if you already cancel the subscription. If you change your mind, then if you want to continue enjoying the subscription, you can do the reactivation. Then the auto renewable status will turn back to on after you already canceled the subscription. Then it will go to the renew flow as per normal. You will get your entitlement in the next cycles. Okay, so for subscription, this is the different part, subscription and consumable. So there is a renew because subscription is a recurring process. So depends on the cycle of the subscription. If it's, let's say, 30 days, at the end of the expiry date, if you don't cancel the subscription, it will renew. So we will extend the subscription period, depends on how long the subscription period. And also you don't need to, you also don't need to do anything because we will charge the payment method directly. So without user intervention there. Okay, so if you cancel the subscription if you cancel the subscription without doing anything, without the reactivate again, it will go to the expire. So yeah, so subscription will expire occurs when current subscription period comes to end without the renewals. So the user, to get the entitlement back, user needs to do the new purchase or just buy. Yeah, user need to go to the first flow, which is a new purchase again. Okay, same as consumables, the user can also apply for refund if they think the host is fraud. For example, like the sticker is not really aligned with what they describe, or they think there's something wrong in the subscription, something wrong with the host. They can apply for refund. then depends on the channel risk control or their decisions. They can either approve or reject the refund request. So if they approve, the user will get their money back. And as a developer, we should revoke the user subscription. Okay. Now the previous one is the happy flow. Now we go to some of the edge cases. So in subscription, right? For every renewal, we will try to charge the user's payment method. But what happens if the payment method is failed to be charged? For example, like your credit card is expired, or you change your credit card to some other invalid credit card. So when this happens, the users we will inform the users that they need to fix their payment method to continue the subscription. So as a developer, we should revoke the user's entitlements. So the user cannot enjoy the benefit anymore, but it won't go to the expired state because there's still a chance because the channel still keep retry to charge the user's payment method there. Okay, so if the users able to fix their payment method during this on hold period, the subscription will go to recover state. Recover state is just basically just a renew, but the period will be shift to the recover start date. So for example, like you buy a subscription on 1st January, it should be expired. If let's say the subscription length is 30 days, so it should be expired on 30 January. And if your subscription is go to on hold period, let's say it's recovered at 7th February. So the new cycle of your subscription will be 7th February to 7th March. So because the user don't pay for 1st February to 7th January, so we will renew the cycle period for the users. Okay. As I mentioned before, so if the users fail to do the payment, channel failed to charge the users, it will go to on hold period. So during this on hold period, actually channel will keep retrying to charge the user's payment method for certain period of time. Usually it's either 30 days or 60 days. So at this time, user won't get the entitlements. Okay, so depends on your settings. We can also have a grace period. So before transit the user from active to on hold, we can have a grace period where the user did not pay for the subscription, but we give the user free entitlements before we transit the user to on hold period. Yeah, so at this period, the users still need to fix their payment method, but they can still get the entitlement. Usually, this grace period is a bit short time, like maybe 1 or 2 days. Depends on your business decision, of course. Okay, the next thing is the defer renewals. So we can extend the user expiry date without the user paying for it. So the use case of this flow, usually if there is an event, for example, you want to give a free 1 or 2 days for every users, or for example, you want to compensate if there's a system down. For example, system down for 1 day, then you compensate the user. You extend all the subscription length to 1 day, something like that. And also the user don't need to pay for the subscription. Okay, then also there's the previous flow that I mentioned is a subscriber initiated action, but hosts can also do something with the subscription. For example, they can do the price change. Hosts can change the price to either higher or a lower price. So for every user, they need to agree with the changing of the price. If they not agree, it will automatically cancel. But usually for higher price, they need to explicitly agree with the price changing. But if the host change to the lower price, usually we don't need the user consent because yeah, it's a benefit for the users. Okay. Also, this one is this one is for subscriber perspective. They can change their tier. For example, like if they I if the host have a three tier, silver, gold, or diamond, users can change from silver to gold or gold to diamonds in the middle of the subscription. Okay, so this is the overall subscription lifecycle. It's a bit more complex than consumables, but I can go through some key points of the subscription lifecycle. So we have some of the important state of the subscription. There's an active, canceled, expire, grace period, and on hold. I think we can ignore pause for now. So yeah, if the subscription is renewed, it will always go to active. When the user start do the soft cancel, it will go to canceled. And if it's past the expired time, subscription will go to expired state. Then if the user failed to renew, but they don't cancel the subscription, it will go to grace period. Then from grace period, will go to on hold. At this two state, channel will hit retry to charge the user's payment method. Then if everything's failed here, it will go to expire state. Then expire state is the final state. So if you want to buy the subscription again, you will need to go to the subscription purchase again. Okay, so we already covered the business domain, the consumable and subscription. Now we can go to the order or backend perspective. So I draw a simple diagram and how to handle the coins and subscription product. So let's say there's two surface here, coins and subscription, because each of the business also involving the transaction, the order, we can have a order surface in between. So order surface will keep track of the order DB. Then for every transaction, we can verify the correctness of the data to the channel. Channel is either Apple or Google. Yeah, so this is the simplified version of the order entity. So we can have the order ID, the business order ID. This one is the coins or subscription ID from the other surface. We can also have the user ID, the channel order ID. Channel order ID is the order ID on channel side, on Apple or Google. Then we can have the SKU ID, for example, like the product ID, for example, like 70 coins, or is a subscription. And we can also have status like if the transaction is in pending state, waiting for the payment, or is a complete state, or is already refunded. Okay, so I give some simplified service API that can support the order life cycles. So when we create the order, when we click the user want to buy this item, we can have a API to create the order. For example, like post order, then we fill every details, the business order ID, user ID, then SKU ID. Then in the background, after we do the validation, we can have a SQL statement to do the insertions, insert order, blah blah blah, and we go to the first status, the pending state. Then to update the order to either success or fail, for example, the user already finished the payment, we can translate the order to success. Then we can have an API, like for example, like put, can have a /order /the order ID. Then we pass the channel order ID equals the channel ID from the channels and the status to either success or failed. Here we can have a SQL statement, update orders, set blah 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 equals success, where IDs equals blah blah blah. Okay, now if we want to get the order detail, for example, like if we want to have one, we can have a get or /order /ID, and the SQL statement is select star from orders where ID equals 1. One thing to note is if as the data grows, we should really care about the rate performance. So we can also consider to use index here. usually primary keys like ID is already indexed by default from the DB. So this query should be fine. Next one. Okay. If we want to get all transactions, all orders from the particular users, we can have a API, something like this, slash orders, where user ID is equals the user ID. Yeah, the SQL is select star from orders where user ID equals blah, blah, blah. And we can order the order by the created at. And then here the proper index, maybe we can have the composite index of the user ID and created at. So when we query this, when we hit the DB using this query, it will go through index. So it reduce the load time from the DB. Okay, so now we can go to the purchase. Yeah. So in the purchase flow, one thing we need to really do is to verify the payments. So after a user make the payment, servers needs to check to make sure the detail match with what the user provided. So when we do the verify, we will approve or reject the verify payment. If it's match, if the detail match with what the channel data, we will approve the payment. Then we will transit the order state to success. Then we can grant the user the entitlements. If we realize that the data is incorrect, we can just drop the verify payment. Then we can transit the order to fail. Next one. Okay, so there's there's two way to do the verify payment. The first one is by client side. So users can post a request if they think that they already have the payment detail. They can pass the item information like business order ID and channel order ID. And we as a service, order service, we will call channel, Apple or Google. We will try to check if the user information is correct. If it's correct, we can translate the order to success. And another part is we can also do the verify payment by the server. So after the users already complete the payment, usually channel will send us the notification that tell us, oh, this order ID with this user ID is already complete. So now we can do our own thing. So as an order service, we need to verify the validity of the channel message, channel notifications. Then if everything is correct, we can translate the order to success. Then we can pass the user the entitlement. We can give the user coins or the subscription. Okay, so in terms of security, there is some method that we can use. For example, like to communicate with channels, usually we have a API key or tokens because not everyone can access the user's data from channels. So we can have a shared agreement between server and our server and channel side to use this API key or token to call to get or update the user's data on channel sides. So this token of this API key actually can also use as a rate limiter. So channel can identify the token, then can set some kind of rate limit so we don't spam too much request to the channel side. And for the notification we get from channels, for the verified payment from a channel to server side, we can utilize the JWT, this JSON Web Token. So JSON Web Token is a signed data. So there's three parts in JWT: header, message, and signature. All this is base 64 encoded. So we have the algorithm part here in the very top. There's a message here. This is the real data that the channel sent us to us, and there's a signature. So signature here is to verify the validity of the channel notification because we already have the secret key that is shared between server and channels. Then we can just check if this message really comes from channel side. Okay, now we can go to the last part. Some of the best practice that we can use to handle backend. First is state machines. State machine is the transition of each state and which action can be applied for a specific state. So there's some benefit in the state machine. We can visualize the logic and also prevent unexpected behaviors. For example, here we have three state: active, expired, and canceled. And each state, there's only we can specify which method can interact with the state and what is the transited state after this method is applied. And we can also verify if the method is not applicable. For example, like you cannot reactivate expired state here. So it's easy to visualize and understand. There's also important of log. Log provide a timestamp record of events, errors, and transactions within a system. It's essential for diagnosis issue, understanding user behavior, and auditing system activity. So for example, if there's a user's complaint, right? Oh, I don't get my coins. Aside from checking the DB, the database, we can also check what really happens in the service level. So by using logs, we can really know what happened in the system. Because we can track per code line level details from the log like this. There's also metrics. There's two type of metrics. System metrics usually is measure the throughput, latency, error rates, and that reflects the operational aspects. So usually developer use these metrics more. And there's also business metrics. For example, like the conversion rate, user engagement, and other indicator of business success. So for business team can use these metrics to determine which directions the system will go. Then the product will go also. Okay, and the last part is the reconciliations. So reconciliation is a process of matching records from a separate database or separate sets of data. It's applied to ensure the transactions data across various platform surface or database remain consistent. It can also use to identify discrepancy early and preventing a fund loss or there's a data integrity issues. So I can share some example of the reconciliations on the next slide. Okay, so for example, we have two data sets, channel order and our own order systems. And in the order, channel order is an order coming from Apple or Google's. They have their own data. Let's say they have ID 123 and price 537. And in our data, we also have a data ID, this ID 1001 with channel order 2, price 3, and so on. Then here we can do the inner joins. For example, like for every channel order ID, is there any correlated order system ID? Then we can also check if it's both exist. We can also check if the price match. If the price is not matched, means there's something wrong in our handling. If the channel already exists, but order system is not exist, means that we miss some of the order in channel side. Then we can try if we can do something to compensate of this order loss. Yeah, I think that's all from money platform side. Now I can pass to Raymond to give more sharing about the wallet system.
Sure, thanks, Brain. Hello guys, I'm Raymond from the wallet team. So I will give a brief talk about the wallet, how the wallet is works. Next slide, please. So basically, this brief talk I will talk about two kind of questions. So first one is what is a wallet system? So the second one is how to build a wallet system. Okay, next slide. Okay, so what is the wallet system? So roughly, wallet system include 5 parts. So the first part is base page. So as we all know, so we need to display to the user what kind of money, what kind of scores the user earning, the user can get from the life cycle. So mainly for the balance page, it displays some UI to the users, how the additional information, how the money the user can earn. And so the next one is a account system. So basically for the account system, as we all know, so the computer science, so all the data we maintain from in somewhere in some computer, right? So all the user in your bank card in your, so we need to save the user data about the balance, how much balance the user earning, how much balance, what kind of transaction the user in this day happen. So mainly for the account system, we will maintain the balance. For the transaction system, so in the transaction world, you can see that I want to transfer some kind of money from my side to your side. That means we need to have some system to provide this ability to ensure the transfer can be works. So this is the transaction system. So the next part is a purchase system. Okay, so as Brian just now talk about, so the user how the TikTok interaction with the outside channel like Apple Pay, Google Pay, and so on. So how the user purchase the money and get the coins. So roughly the purchase system is do that thing. You interaction with the channel and get some coins in the TikTok and so on. So this is the purchase system. Okay, so last part is a withdrawal system. So it's a straightforward kind of thing, right? So withdrawal is just let's say the host get the money from the TikTok, right? So we need the host allow to withdraw the money from the TikTok to the bank card. Roughly the withdrawal system is do that thing. Okay, so that's thank you. Okay, so you can basically can check what kind of balance page look like. So you can just open your TikTok and to display to check what's the balance entrance from this picture. So you can see that the right picture, the first one is the username, previous balance and current, and next part is the current content reward, the user, how much money the user earn, and how much money the coins balance, and how much money for the other earnings, and so on. And for the bottom metric, that is for the user level, frequency, package the user used, and the transaction, entrance, and the tax information, and the help center, and so on. Roughly, the balance page just show the user information to let the user know how much, what kind of information the user have. This is for the balance page. Next slide, please. So for the account system, actually account system is at the bottom of the user for the wallet. So account system just maintain the user, TikTok user virtual assets, provide the transaction bottom layer transaction abilities, and to just provide the transaction ability to the outside, like say the purchase system, withdrawal system, and transaction system, and so on. So account system, the key part is maintain the user balance. We need to ensure the user balance not wrong and the user balance display correct and so on. And another part is that for another ability is that the balance transfer. So you can understand, you can consider as we save the user balance in account, we need to ensure what kind of account move from what kind of user to another user. So mainly for the account system will provide this part. Next slide, please. For the transaction system, so as account provide a transfer ability to the top layer. So actually, transaction system is the top on the top of the account. So you can consider that the transaction use account transfer ability to finish the transaction ability. Let's say the user currently have some coins, right? So the user in the live world, in the live, the user can consume the coins to send the coin to the host. So that means the user coins deduction and the host diamond increased. So basically, this is the transaction system works. It's from one user to another user. And actually the transaction system including a lot of part, not only the coins consumption, but also the envelope, water, and so on. Water system is basically can understand like the user in the live room send the envelope, and then the user can get some free coins in the envelope and so on. So basically the data transaction system working. Next slide, please. Okay, so personal system. Personal system is furnishing. You can see that the user coins, it's not need to come from another where, right? So person system is do that things. The user can purchase from different channel, just Brian mentioned, maybe from the Apple Pay, Google Pay, web app, Azuma Pay, and so on. So that is the purchase system means just interaction with the channel side, and if the user payment purchase successful, and we will add a coin to the user. This is the purchase system, and the user once the actually this is the release on lots of technical design is need to front side, the client side, the channel side together to finish the purchase system. So once the purchase, you can see that this in this flow, the user buys the 20 coins in the TikTok. The bottom layer, once the user finish the purchase, the Apple Pay will give the notification to the client side, and the client side will notify the server. Server will give the server will go through the purchase system, issue the coin to the user, and the user can use the coin to the send gift. Roughly, this is the flow for the purchase. And okay, next slide, please. Okay, so withdrawal system. Actually, you can consider the purchase system is main focus on the user side, but how about the host side? So the user consumption the coins to the host, and the host can get the diamond. So this is for, and after the host gets some diamond, the host can withdraw the diamond. So this is the withdrawal system do. The host just in the withdrawal system click this is the UI display. The host can click the withdraw button and then type what kind of how much money the user want to withdraw, and the withdrawal system will interaction with the some outside channel like bank card, some bank card to really transfer the money from the TikTok to your bank card. This is the withdrawal system. Okay, next slide, please. Okay, so as just now I mentioned, so roughly what including the user display and the purchase system, transaction system, withdrawal system, and the bottom layer account system. So I will give a brief talk how to build a wallet system. Next slide, please. Okay, so roughly the architecture like this. The display is a top layer from to the user. That means all the user can see what kind of information to outside all the display layer do, and within the display layer, actually in the middleware, so we have the purchase, transaction, and the withdrawal. This is a very key part, three part inside the wallet. Purchase maintain for the how much interaction with the channel side. So the channel, we can get the channel successful signal, and we can add some virtual coins in the system. This is the purchase system too. And for the transaction just mentioned, so in the left give scenario, the user can send the coins to the host. So one user to another user. So this is two people guide, right? So this is the transaction duty to provide ability to outside. For the withdrawal, once this guy have the money, right? So this guy can withdraw the money to outside. So this is the withdrawal system. And as just mentioned, we have this is the three part on the middle layer, and the bottom layer is account. So account maintain all the user data. So like how much coin, how many coins the user has, how much money the host have, and so on. So remember, account is the bottom layer, provide the transferability and the maintain the user money. Okay, so next slide, please. Okay, so actually in this talk, I will only talk about the account system. So why we need to build, let's say if you want to build a wallet, why we need to build an account first? You can see that everything in the top layer all based on the account. Once the account are set up, it's very easy to top layer to do some more transaction abilities. So account is a very important thing we need to initialize first. And with if we don't build account first, if no, let's say the user no account, so there is no transfer, right? The transfer action don't know what kind of transfer happen, what kind of user account transfer, what kind of money to the another users. So that's why in this talk I will talk about the account first. Next slide, please. Okay, so as an account system, we need to consider how to build the account. So the first important thing we need to determine to choose the storage, right? So usually we choose some database to maintain some user data, and the database we have some relation database and NoSQL. So when we initialize the account, we need to consider what kind of database type we choose. So this is from the storage choose level layer, and from another part is the computing. So let's assume currently we already have the storage. So how the computing we choose? We have already saved the user data, and what kind of computing action happened in the compute layer. This part is also we need to think about. And as the storage layer and the computing, we have a make decision, and the another part is we need to consider the storage schema, like how the user, how the structure of the user data we design, how the interface we provide upstream, what kind of transaction model we choose to suitable outside transaction scenario, and so on. This is all of things we need to think about. Next slide, please. Okay, so from the story layer, we need to think about the two part. The first of all is what kind of do we need to choose a relation database or NoSQL? Actually, relation database we have some benefit, right? And NoSQL we have some benefit. So what kind of story we can choose? If so in the computer in the what level, so we need to, the first thing we need to guarantee is that user data cannot be lost. This is a very important thing. You can see, consider in your back card we have some balance, right? The citizen to disappear, we cannot accept this. So we need to guarantee the user data cannot be lost. Relational database is the first thing we need to choose it. So the reason that it meets on the SAID standard, and also we need to provide the relationship to the outside to use like the Slack for update and query and delete and insert and so on. This is some struggle relationship things. So that's why we choose a relation database. Next slide, please. Okay, so and now we choose a relationship database, and we need to think about what kind of table we design, right? So let's say one user. First of all, we need to make a decision. We need to maintain the user balance first. So account balance table is needed. At least we should have the user balance, so we can do another action like the transfer from the user A to user B. So account balance is needed. And another part is that this part we need to take note. So one user maybe have the multiple account. User level, you can consider TikTok user level is a one user, right? In your TikTok account. But from the wallet account level, one user maybe have a multiple balance. How to understand like this thing? You can consider you purchase some coins, so you have the coins account. But how about if you are user also have is a host? So that means if you open the live, maybe you can get some diamond. We also need to set up the diamond account, right? That means from your account, you have the coins account, have the diamond account. So that means one user have multiple accounts. This part we need to pay more attention about during the design. And for another part is balance record table. So how to understand this part? You can consider, let's say I transfer coins to the host, right? So we need to record, we need to write down the record in our database. So if no record, how do we know what kind of coins you spend? How do we know how many money the host earn? So this is the key, another key table. So account balance and balance record. This two table is very important. Next slide, please. Okay, so from the account, from bottom layer account storage schema, let's say account balance. First of all, we need to account ID. What means account ID? Actually, when every user have the unique ID saved in the storage layer, this is very important. We can buy the account ID to get the this user information to show outside. So account ID is a very important thing. And account type, just I mentioned, if you one user is a coin, have the coins, and also have the diamond, have the cash. So we use account type to distinguish. And balance is very easy to understand, right? So balance is just how many balance amount inside your wallet and so on. And for status, this part, let's say if your account never used, maybe you don't use this app anymore and so on. Maybe you have some scenario cannot use this account, so we just block setups another status to block this transaction happened. Yes, this is status. And from the create time and update time, it's easy to understand. When this account initialized, we will update the create time, and after that time, every time this balance for this account type updated, we will change the update time. Okay, so this is for the account balance table. Next slide, please. And from the balance record, like just mentioned, balance record, every money transfer, we will record inside the balance record to ensure we have some record to record the action. So first of all, ID is just database increase ID, and no need to talk about this part. And order ID, order ID is important things. So you can consider your bank card. So every transaction happen, you have the unique order ID to record this transaction is a unique in the storage layer. And order ID, order name is simple, just a description. What's kind of transaction scenarios that happen, and account ID, account name, just I mentioned, we need to know what's kind of unique ID, right? And operation type. Operation time is funny things. How to understand the operation time? You can see that user A transfer to the user B. That means user A money deduction and user B money increase, right? So operate time is just that means one is deduction, one is deduct, one is another is increase. It's opposite. This is the operation type means, and balance is you understand this transaction happens with the balance amount, and create time and update time I not mentioned. Okay, next slide please. Okay, so just talk about the very basic account storage, how to design. Keep in mind, we have two tables. One is accounts balance, another is a balance record. So as we have the storage layer, we need to think about how the interface design. So so we need to provide the ability to offside, right? So if we don't have provide this endpoint, how the offside, like a purchase system, to add the coins to the user, how the transaction system to transfer coin to the host, how the withdraw system to withdraw money from the account to the bank card. So the endpoint interface is very important. So basically we need to provide two kind of key interface. The first one is trans. What does it mean trans? Trans actually is a transaction. So transaction is a straightforward, can do the transaction from just a transfer from A account to B account. So this is this interface design. And another part is a get trans order. For the trans, we have two kind of part. Another one is the debit part, and another is credit part. Just now I mentioned, user A need to deduct money, user B need to increase money. This is the transfer, right? That means user A is debit and user B is credit. Keep in mind, debit and credit. And from the another part is get trans order. This is very easy to understand. We just want to know this transaction status is successful and failed. This is the get trans order. Just provide a query interface to offside. Next slide, please. Okay, so the interface I share about the trans interface, how to guarantee how the transaction model will work like. So you can see that the account ID 123, and they have another account is 456. So on the very beginning, the 123 have the 100 money, and 456 have money is 0. And 123 want to transfer 100 money to the another account 456. That means 123 need to deduct 100, right? And 456 need to edit 100. It's very easy to understand. This is a very basic transaction model. So in this part, we need to think about how to guarantee the debit 123 deduct successful and 456 increase successful. What's going to happen if the 123 deducts 100 successful, but 456 have not increased 100? That means the data lost, right? So the fund lost. The user 456 have no money get in. So this part, that is the interface design we need to think about how to guarantee the transaction successful. Basically, from this part, we have so many ways to guarantee. In there I only talk about one ways. Can you next slide please? Okay, so how to guarantee? It's very easy, straightforward to understand. Inside the DB transaction, when the transaction happen, we use a database to guarantee. This is one way to guarantee. They have another ways. So this part is we guarantee by the database transaction. That means once this transaction happen, we need to open the database layer transaction. The database layer transaction, that means if the 1, 2, 3 not commit, the 4, 5, 6 cannot edit at will. So we use a database transaction to guarantee. The detail is just select for update some for 1, 2, 3 users, and we handle the debit. The debit logic is 1, 2, 3, deduct money 100, and the credit side we need to add increase 100, right? So we handle it. At that moment, the user data have not been updated, so we commit the DB transaction. So once this happened, the user, the 1, 2, 3 and the 4, 5, 6 will commit together. That means these two users all finish the transaction, one deduction and one increase. This is a very basic scales of the DB transaction. So we use this to guarantee in this way. And so from a data layer, you can think about we insert two balance record. It's why we insert two balance record. So you can consider the 1, 2, 3 deduct 100, they have the one record, and 4, 5, 6 increase 100, we have another record, right? So we need to record the action for both way. So that's why insert two balance record, and the updated two account balance is you understand 1, 2, 3 from 100 to become to 0, and 4, 5, 6 from 0 to 100. So when to insert, to updated. Next slide, please. Okay, so so after we finish the story layer and the interface design, how do the computing layer? So roughly, if you want to provide this ability, we need to think about how to make your server run, right? So your server, usually if you just use a laptop, so just run in the locally, this means this is a single server, right? But how do we handle if the user have so many? Let's say your single server can afford maybe less than 100 users transaction, but how about 1,000? How about 1 million users transaction? How do we handle? So if that, we need to deploy your service in the cloud. So this is very straightforward, right? So we from the one single server become to the multiple server and deploy the clone. We have a multiple server save the provide ability at the same time. So this is the computing layer. Based on the cloud, we have the multiple ports in the cloud. So every port can provide this ability. That means you can hold so many user transaction. Okay, this is the account computing layer. Next slide, please. Okay, so so this is from the keep in mind. This is the transaction model. Like just now use a very basic simple to talk about what is debit, what's the credit, right? One user deduct 100 money is debit, and one user increase 100 money is credit. So the wallet is a very funny thing. It always happen on the two kind of way. One is debit, one is credit. So do some transfer logic. So this is a very basic transaction model keep in mind. So we have two parts, credit and debit. Next slide, please. Okay, so after that, we have the storage, we have the interface design, and you deploy your interface into the single server or clone. You can provide the offsite ability, right? You allow the offsite to use transaction abilities or purchase add some coin in the user account and withdraw some money from that account. So this is the basic model. But how to do the global business? Because we cannot global business means the global we have so many countries, right? Every countries the user have their own data. How we need to determine what kind of user data in the which kind of data center. We cannot use only one data center to focus on the global business, right? So we need to make a decision. What kind of data center we choose. So roughly, there have three parts we need to think about. The storage. If your storage, let's say, if your storage maintain 1K user, maybe possible. If you storage maintain $1 million, maybe also possible. If you storage maintain 1 billion users, how do you handle this part? Because the user data maybe have so many, you need to locate the different user data in the different data center. How do you handle the different data center transaction? This is another part, another story in the future. Maybe you should meet it. And from the computing, also, just I mentioned, as you have the user data and how to do in the global computing logic, how the architecture you design. So one single is different. One single layer is different. Compared the multiple layer. So the multiple data center we need to pay attention. And another part is a transaction model. Let's say just I share a very basic version, one credit, one debit, right? How to handle if you want to transfer, if user A deducts 100, but user B add 500 and user C also adds the 500. That means one from two, they have two, right? So that means how to handle one debit, two credit. So how to handle multiple credit, multiple debit. So this is another topic. Another topic is a very complicated transaction model. When we design the transaction, we need to think about. And so from the overdraft, let's say the user should the money should be more than zero, right? But how even they have some scenario, maybe the user money less than zero. So if the user have the overdraft amount, how to do the transaction transfer model? Cause the user at that moment, the money already less than zero, how to transfer to another user? So the overdraft during we design, we also need to think about. And from the freeze, freeze is a similar with overdraft. Let the user have some money, but the money cannot be used immediately. How to handle this part if the user have the frozen money? So we also need to think about how that part how to design during the account side. And they have the last part is from the multiple currency. Let's say, every country have each of currency, Singapore dollar, USD, and so on. So how to transfer? How to transfer within the different currency from the debit and the users? So this part is a very tricky thing. We also need to think about. Okay, so that's all from my side to share. So roughly, let me summary about this part. Wallet, we have the display, purchase, transaction, withdraw, and the bottom layer account. And before we design the wallet, we need to think about how to design the account. And the account, first of all, we need to think about the storage. We need to think about the interface design. We need to think about computing, and we need to think about the so many user handling and data center and currency current handle and so on. So this is that's all today I'm sharing. Let me hand over to AB. Thank you.
Thank you so much. I think today is a very fruitful session, and thank you both for your time to do the sharing here, and also thank you all for all your very cute emoji and reactions. Now we will open the floor for the questions. So since there are only like limited time left, so we will invite back Brian to pick 2 to 3 burning question which is commonly asked.
Sure. Let me answer some of the question. Okay, I think Lim Yi Xiang asked that you mentioned that storing logs is considered as a best practice. Can you elaborate how logs will be stored since the number of logs will be grow so large? Yeah, how will you handle the management logs? So for logs, yeah, I agree with you. The number of logs can grow so large. That's why usually we have TTL, time to live. So the logs usually we only store for, depends on your use case. We can store the logs for 7 days, 14 days, or 30 days, or even 1 year. So the size of the logs won't grow so much because we limit the time when we store the logs. And also for the data the database we can use for the storing the logs, we can use Elasticsearch because it's very optimized for searching some of the keyword. Yeah, so you can take a look if you want to dive further. You can take a look on the Elasticsearch and also maybe Kibana to store the logs and search the logs also. And Raymond, do you want to answer some question?
I think we just answer like one more question from Raymond. You can pick one from the question list.
Yes, okay. So I can answer what's exactly from the an important check and how does the record tool entry for the both balance record and account balance have to actually do. So good question. And important in the what layer is a key issue we need to solve that. First of all, we need to ensure an important logic. That means one transaction, the credit layer increase one money, right? So we cannot increase two kind of money for this. So first of all, we have the snapshot. Before the user transaction, we need to query the snapshot first to check whether what kind of transaction happened before. And after we check, we also have the story layer to guarantee. Let's say if the user using Queen ID have already successful in our storage, this transaction cannot happen again. So use the story layer to guarantee. So by this way, another part we have the Reddit log to guarantee to ensure the high traffic cannot come together in the same time together to release our traffic to release our traffic not so big. And actually they have a lot of endpoint check, but basically you can think about roughly we have two level. First of all, we have snapshot to guarantee that this transaction cannot happen again. And the second level is we have database unique level, use the database to guarantee this transaction cannot happen.
Okay, got you. Thank you for the clarification for the question. So now since we are about the time, so we will end this session first. And thank you all for your joining, for your time here. And don't forget to check in by scanning the QR code on your right hand button. Okay, so yeah, and we will keep you updated about the recording for today's session in our information doc. Our next session will be next Tuesday, which is 21st May, talking about privacy, which is another burning session here. So don't forget to join us, and also keep an eye on our information dot. We'll keep you updated on our Telegram group. Please scan the QR code for the Telegram group to keep an eye, follow with updated information for the Tech Immersion TikTok 2024. Thank you all for your time. I will end up this talk. Please feel free to leave the room. Thank you.